Imagine the scene. Right at this moment, your phone vibrates violently. Immediately after, the shrillest emergency alarm you have ever heard blares out. An ultimatum from the Global Science Union appears on the screen. A cold, ruthless verdict. Earth has only 10 years of habitability remaining. It is no longer a game of probability, but a cruel countdown until the clock hits zero. Perhaps an unknown asteroid is hurtling toward the Pacific at annihilation speed, triggering a 1,000-meter tsunami that will engulf entire continents. Or perhaps the Earth's magnetic field, which secures our existence, suddenly collapses, and the solar wind mercilessly strips away the thin atmospheric veil. Regardless of the cause, the result is the same. We must flee immediately. We must leave this cradle from which our ancestors gazed at the stars. But here lies the problem. When we turn our gaze toward deep space, guided by the instinct for survival, only a stifling silence answers us. This thoroughly cold silence is the most immediate fear the Fermi paradox instills in us. The universe is so immense. Why are we so alone? On our journey today, we will conduct an extremely serious, even cruel, survival simulation. We will evaluate the so-called candidate homelands, one by one, tearing down their beautiful facades to see if they are truly bearers of hope for human civilization, or if they are disguised death traps. When we rush headlong into the search for habitable planets, our eyes first fall on the celestial body closest to us, the moon. In the night sky, it appears as a tangible refuge. Yet, this is precisely the first trap. The moon is a death zone without atmospheric protection. Human civilization would have to live like cave dwellers in bunkers buried deep beneath the surface. The surface itself is lethal. Even if you stepped outside for just 1 minute, the unhindered, intense cosmic rays and high-energy solar particles would shatter your DNA structure and trigger irreversible cancer formation. But radiation is not the worst. The most despairing killer is the lunar dust. These tiny particles have not become harmless like the sand on Earth. Since the moon has neither wind nor water, these dust particles have retained their most primitive form. They are like countless, tiny, extremely sharp glass daggers carrying a strong electrostatic charge. They adhere everywhere and penetrate precision instruments. Once inhaled, they get hooked in your lung alveoli, causing permanent pulmonary fibrosis. As a home for billions of people, the moon is clearly a cruel joke. Since the moon is unsuitable as a stepping stone, we must turn our gaze to the red planet, Mars. It is the dream destination of science fiction. But if you strip away the filter, the real Mars is far more adverse. First, the temperature. The average temperature there is minus 63 degrees Celsius, which is colder than the coldest Antarctic winter. Furthermore, the Martian atmosphere is extremely thin, its density only 1% of Earth's atmosphere. It can neither retain heat nor block the deadly ultraviolet radiation from the sun. Even more lethal is the soil. The Martian surface contains a high concentration of perchlorates. These are chemical substances that are highly toxic to the thyroid gland. Simply put, Mars is a dead planet filled with poisonous soil and bombarded by radiation at every moment. To grow plants here, a complex chemical detoxification would first need to be carried out. Do we want to transform it into a second Earth? That would require gigantic orbital mirrors or an artificial magnetic field, an undertaking that might take millennia. Given the immediate Earth crisis with a 10-year window, the red planet is rather a beautiful lie. Since the inner rocky planets are disappointing, we look further to Jupiter's moon, Europa. This is a frozen world. Beneath its dozens of kilometers thick layer of ice lies a vast, bottomless ocean of liquid salt water. This sounds like a paradise for life. Yet, for humans, it is an icy purgatory. Not only would we have to brave the extreme cold, but also the most terrifying radiation source in the solar system, Jupiter. Jupiter's extremely strong magnetic field traps a large quantity of charged particles, forming a lethal radiation belt. Unprotected on Europa's surface, the radiation intensity would be strong enough to tear apart your cell structure in minutes. We could only live forever hidden beneath the thick ice layer, languishing in eternal darkness sustained by geothermal vents. Is this truly the future we desire? Since no planet in the solar system can truly replace Earth, we must make a heartbreakingly difficult decision to leave the solar system. But here, humanity is confronted with the most ruthless and insurmountable physical law of the universe: distance. To give you a sense of scale, if we shrink the sun to the size of a basketball, the nearest star to us, Proxima Centauri would be 7,000 kilometers away. Even with the fastest human-built craft, it would take tens of thousands of years to reach Proxima Centauri. This means this is no longer a journey, but a penitential pilgrimage spanning hundreds of generations. The social structure of such a generation ship is extremely fragile. In a closed ecosystem, any small mutiny, a flu epidemic, or a technical failure could trigger a chain reaction that annihilates the entire human civilization in that dark, cold abyss. Suppose we have incredible luck and reach the exoplanet nearest to us, Proxima b. Data suggests this planet lies in the habitable zone. Yet, if you truly fly the ship closer, the beautiful illusion will be instantly destroyed. The reason is that its parent star is a red dwarf, dimmer, but also fiercer. To ensure liquid water, Proxima b must orbit extremely close, causing it to be tidally locked. This means this planet has no day-night cycle. One half is in an extremely hot, eternal day, the other half in an extremely cold, eternal night. The atmosphere streams wildly between the ends, forming superhurricanes. Only in the narrow terminator line, the boundary between day and night, would survival be barely possible. But that is not the worst. Red dwarfs are extremely unstable and regularly eject superflares. Their intensity is hundreds of times stronger than the solar flares of our sun. These flares would repeatedly strip away the planet's atmosphere and instantly carbonize all life on the surface. Living here would mean constantly waiting behind thick radiation shields, trembling in anticipation of the next stellar storm wash. If we search further, we will encounter the once sensational planet, the Earth's bigger cousin, Kepler 452b. Its parent star is nearly identical to our Sun. However, this planet has a diameter 60% larger than Earth's, which means its gravity is roughly twice that of Earth. Your body weight would double, your bones would groan, your heart would have to work under overload. In such a strong gravity environment, simple walking would be an intense workout. Even more unsettling is the time factor. The parent star is 1.5 billion years older than the Sun. As they age, stars grow brighter and release more heat. Scientists suspect that the oceans on this planet may be undergoing a runaway greenhouse effect. The seawater is evaporating quickly. We travel 1,400 light-years, only to witness the tragic state of Earth a billion years from now. This is a world that has already entered its twilight. Our journey, there would be nothing more than visiting a funeral. Besides Earth-like planets, there are the so-called sub-Neptune planets, such as K2-18b. Scientists suggest that these planets could be entirely covered by bottomless oceans. Although water is the source of life, a world without any land is despairing for land-based creatures like us. The sea depth could reach hundreds of kilometers. At the bottom, the liquid water would undergo a phase change under extreme pressure, turning into a bizarre form of high-pressure ice. For example, Ice 7. This hot ice blocks the material exchange with the rocky mantle, which could deprive the ocean of important minerals and nutrients. If humanity migrated here, we could only live in floating giant cities or submarines. Without mineral resources and without the means to smelt metals, civilization would lose its foundation and slowly degenerate in this endless body of water. Suppose we found a perfect planet with suitable conditions, like T-Garden B. We would still have to face a final biological nightmare, biological incompatibility. We are the product of 4 billion years of Earth's evolution. Our immune system and every cell are precisely designed for the terrestrial biosphere. If there is indigenous life on another planet, their biochemical rules might be completely different from ours. For example, the chirality, handedness, of their amino acids might be opposite to ours. This means the seemingly juicy fruits on that planet might not provide us with nutrients, but turn into highly toxic chemical mixtures. We would starve to death in the lush Garden of Eden. Even more frightening are unknown viruses and bacteria. Our immune system is completely foreign to them, lacking any recognition or defense capability. An ordinary cold virus from an alien star could become humanity's super plague. In the extraterrestrial ecosystem, the human being might be an eternal foreign body, forced to constantly live in sterile isolation domes. If we cannot find a perfect home, why not just build one ourselves? The physicist Gerard K. O'Neill proposed the concept of the O'Neill cylinder, a gigantic space colony that uses rotation to generate simulated gravity and can perfectly replicate the Earth's ecosystem. Theoretically, if we disassemble all the material of Mercury or the asteroid belt, we could build enough space cities to house trillions of people and eventually construct a Dyson sphere. This would free humanity from planetary dependency. But this is only theory. It requires an extremely large industrial capacity and an astronomical energy base. The reality is that the current human civilization struggles to keep the International Space Station running. Attempting to build such a gigantic structure before the Earth's countdown ends is an absolutely impossible task. After this long and desperate search, we arrive at a conclusion that is both frightening and incredibly sobering. Within the currently observable universe, there is no single place that can accommodate us as perfectly as Earth. The so-called second homes are either icy hells, radiation-haunted crucibles, or unreachable mirages. This conclusion may sound pessimistic, but it reveals a profound philosophical truth. The relationship between humans and Earth is never that of a tenant to a hotel, but that of a cell to a body. We do not live on Earth, we are part of Earth. Every atom in our body came from the rocks and oceans of Earth. If this text instills a trace of fear in you today, I hope that fear transforms into a strength to protect our existing home. Do not wait for a Noah's Ark to carry us to a new world, for that new world does not exist. When you look up at the stars, please do not forget to look at the ground beneath your feet. For in this immense, cold, and dead universe, the Earth is our last home.